Before we get into it, you need to know what particle accelerators are. The Large Hadron Collider, LHC, at CERN is basically a huge 17-mile ring of super-strong magnets. It's the biggest, baddest particle smasher we've ever built, so strong it can almost recreate the universe's first moments. Could this machine, built to find the universe's secrets, hold the key to even more extensive material? CERN, started back in 1954, is a top research center. With 23 countries involved and tons of scientists working there, it's a hub for brilliant minds to come together and invent. The LHC is CERN's superstar project, but it's only one piece of a massive installation of particle accelerators. Consider it like a racetrack, but for tiny particles. The LHC makes protons go super fast, almost to the speed of light, then crashes them together. This creates energy like what was present during the Big Bang. It gets crazy hot, way hotter than the sun's core. Magnets keep the protons on track, and special coolers keep things colder than space. The beam crashes at 4 points on the ring, where the particle detectors are: Atlas, CMS, ALICE, and LHCb. Each one looks at different aspects of particle physics. They're like giant cameras taking snapshots of these collisions. Researchers look through the aftermath to find rare particles like the Higgs boson, or God particle, and others that could help us understand how the universe is built. By examining the tiniest particles, we can learn about the vastness of the universe. But every time we figure something out, a new question pops up. With each discovery, there's a new challenge. The LHC isn't just a scientific tool, it's proof of human curiosity and how far science has come. It shows our desire to understand the fundamental forces shaping the universe. But as we push the boundaries of what we know, we also have to think about the ethics. What could go wrong when poking around in the unknown? Could we accidentally unleash something we can't control? At CERN, where they're always testing the limits of our understanding, something has come up that's got even the scientists worried. Brian Cox, who used to work at CERN and knows a lot about particle physics, said something that's got everyone talking. The LHC aims to make a mini Big Bang. Yes, a small version of the event that started everything. Cox also talked about the implications, stating that the LHC could help us make major discoveries, like finding out more about the Higgs boson and dark matter, the mysterious substance that makes up most of the universe. Imagine having the power to create the very matter the universe is made of. Sounds cool, but it's also super risky. This mini Big Bang isn't just a theory, it's real. Inside the LHC, the heat, pressure, and energy mimic the conditions at the birth of the universe. It's like being there at the very beginning. But with that much power, we must be responsible. What if something goes wrong? Actually, something did. In 1978, a Russian physicist named Anatoly Bugorsky had a terrible accident. He was working on a particle accelerator when a beam of protons hit him right in the head. It entered one side and exited the other. Remarkably, he stayed conscious and even walked to get help. He was still able to think, but the beam caused tissue damage. He lost hearing in one ear and had facial paralysis. This incident shows how strong and dangerous these machines can be. We can't downplay the risks of a particle smasher like the LHC. There's always a chance of weird reactions, possibly altering the basic laws of reality. This isn't just science fiction, real scientists have expressed real concerns. One of the scariest possibilities? The LHC might accidentally create a miniature black hole. Black holes have so much gravity that nothing, not even light, can escape. They consume stars and behave in strange ways. The idea that the LHC could create even a tiny one is shocking. Could it grow out of control and consume the Earth? CERN scientists insist that any black hole created would be tiny and unstable, disappearing quickly. But even that small possibility has sparked fear, curiosity, and awe at the power we've achieved. To understand how the LHC might make a black hole, you need the basics. When protons crash at nearly the speed of light, the resulting force bends space and time. Imagine a trampoline. Drop something heavy on it, and it sinks. If it's heavy enough, it could create a deep hole that pulls everything nearby toward it. That's kind of what could happen, at the quantum level. There's a theory that extra dimensions exist, dimensions we can't see. If they're real, the LHC might tap into them and form a tiny gravitational pocket, a black hole. This caught the attention of scientists like Stephen Hawking. He suggested that the Higgs boson could become unstable at high energy levels, leading to a vacuum decay that could destroy not just Earth, but the entire universe. Sir Martin Rees, a well-known cosmologist, also expressed concerns in his book Our Final Hour. He discussed a worst-case scenario where a failed test could result in vacuum instability spreading through space and time, potentially annihilating everything. He said it's unlikely, but that the stakes are too high to ignore. CERN researchers have done extensive testing, examined countless theories, and implemented many safety protocols. Brian Cox reassured the public that while the concerns are valid, the LHC operates at energy levels natural to Earth. The chance of creating a stable black hole is extremely low. Even if one formed, it would likely vanish quickly in a flash of Hawking radiation. Still, the idea that the LHC could open a portal to another universe is unsettling. Most scientists don't believe it, but the media has sensationalized it, feeding public fears. So, where did this fear come from, and what does it say about extra dimensions? The idea of extra dimensions isn't new. In physics, string theory suggests there may be more dimensions than we can perceive, hidden but accessible under extreme conditions. Think of the LHC as a key unlocking doors that have been shut for eternity. When protons crash with energy never before seen, they could create ripples that probe these hidden realms. If those dimensions are real, the LHC might reveal them. But again, while powerful, the LHC has yet to show any evidence of doorway-opening events. The mystery of the unknown and the strange rules of quantum physics keep people intrigued. So, should we be scared of the LHC? It's easy to fall into panic when you hear end of the world. But the truth is, CERN scientists are fully aware of the risks. They've taken precautions, built safeguards, and continuously monitor their work. The benefits: understanding the universe, discovering new particles, investigating dark matter, are massive. This isn't about showing off. It's about peering into the heart of existence. Like any big leap in science, there are dangers. We must stay curious, careful, and respectful. The Large Hadron Collider is the epicenter of cutting-edge science. It's where bold theories meet real-life experiments. Its ability to answer the universe's deepest questions, like where mass comes from or what dark matter is unparalleled. Despite the safety measures, the LHC still stirs awe, mystery, and fear. The size of the machine and the energy it produces are staggering. While most scientists are sure the LHC is safe, the unknown always brings possibilities. What if new, strange problems arise, challenges that change how we understand physics itself? A mix of excitement and fear. The thought of wielding that kind of cosmic power, of bending space-time, creating exotic particles, or tapping into hidden dimensions, feels like something out of science fiction. But at CERN, it's science fact. And with each new collision inside the LHC, we're not just smashing particles, we're smashing through the boundaries of what we thought was possible. We're testing the standard model, hunting for supersymmetry, investigating the true nature of dark matter, and chasing hints of a theory of everything that could unite the four fundamental forces of nature. Still, some critics argue that even the smallest chance of catastrophe, like the creation of a stable black hole or a vacuum decay, should be enough to halt these experiments. After all, we're not just playing with atoms, we're playing with the very fabric of reality. But science thrives on calculated risk. Every major leap in understanding has come with uncertainty. Think of nuclear physics in the early 20th century, when splitting the atom brought both incredible power and the terrifying potential for destruction. And yet, out of that knowledge came not only weapons, but also energy, medicine, and technologies we rely on every day. The LHC is no different. It's a frontier lab, pushing physics to its limits, asking the biggest questions humans have ever asked. And despite the fears, the evidence so far shows that it's safe. Nature itself bombards Earth's atmosphere with cosmic rays far more energetic than the LHC's collisions, and we're still here. What truly sets the LHC apart is not just its scale, but its symbolism. It represents what we can do when nations, scientists, and ideas unite with a single purpose: to understand. It's a testament to humanity's insatiable curiosity, our desire to peer beyond the veil of the visible world and uncover the machinery beneath it all. The discoveries we make here might someday explain dark matter, lead to new technologies, or even redefine our place in the universe. But with such discoveries comes a moral duty, to ensure that as we unlock the universe's secrets, we do so with wisdom, caution, and foresight. In the end, the Large Hadron Collider is more than just a machine. It's a mirror, reflecting not only the building blocks of the cosmos, but the ambitions, fears, and brilliance of the species that built it. And as it spins up again for future runs, the world watches, not just to see what we might find, but to witness the very edge of human understanding being pushed just a little further into the unknown. Concerned physicists, such as Stephen Hawking, issued dire warnings regarding what could happen, such as vacuum instability. While the chance of these things is low, the public is energized by the thought of them, scared and interested. For some, the LHC is a symbol of people trying to control nature, a desire to control the forces that run the cosmos. For others, it's a tool to see the basic nature of reality. Trying to learn comes with results. Like with all science, there are ethical problems and risks we don't see coming. What happens when we have the power to see the universe's deepest secrets? Should we stop and think about whether we're ready for the answers we might find? Beyond the known scientific risks and thrilling possibilities of the Large Hadron Collider, LHC, its existence also brings up profound philosophical questions. The scale and complexity of the LHC force us to rethink not just how we know, but what we know. Scientific advancement has always driven the boundaries of human understanding. But the LHC operates on a level where observation becomes abstract, and data has to be interpreted through highly complex mathematical frameworks. This raises a unique challenge. When evidence is buried in layers of quantum uncertainty, how do we distinguish what's real from what's theoretical? Additionally, the LHC highlights the increasingly collaborative nature of science in the modern age. No single country could fund or build a machine of this magnitude alone. It's a collective achievement involving thousands of researchers, engineers, technicians, and students. They come from all over the world, working toward a common goal. That spirit of international cooperation is something rare and valuable in a time when political tensions often divide countries. In a way, the LHC is not just a scientific project, but a symbol of global unity for the sake of knowledge. Another point worth considering is how the discoveries made at the LHC might influence other scientific disciplines. For instance, breakthroughs in knowing about subatomic particles can trickle down into advancements in chemistry, nanotechnology, material science, medicine, and even foundational science. Knowledge from these experiments could lead to better imaging techniques, faster computing, or novel energy sources. Historically, fundamental science has often paved the way for unexpected shifts in technology. When scientists first started studying quantum mechanics, they had no idea it would someday lead to microchips and smartphones. The sheer amount of data generated by the LHC is another marvel in itself. Each second, detectors collect information from millions of particle collisions. To make sense of it all, CERN has had to develop some of the world's most advanced data processing systems and algorithms. The requirement for high-speed, high-volume computing led to the invention of the World Wide Web at CERN in the 1990s. Today, their computing infrastructure spans the globe, linking supercomputers across continents. This immense data analysis capability not only helps in physics but sets the stage for breakthroughs in artificial intelligence and machine learning. There's also an interesting cultural angle relative to the LHC. Because it addresses concepts like dark matter, antimatter, extra dimensions, and the very birth of the universe, it has captured public imagination in a way few scientific projects ever do. It frequently appears in books, films, TV shows, and internet lore. This media exposure is a double-edged sword. On the one hand, it gets people excited about science. On the other, it can spread misinformation or fuel fear-based narratives. Still, the fact that people are even talking about quarks and bosons over dinner conversations shows how powerful the LHC's impact has been beyond academic circles. Meanwhile, ethical considerations continue to evolve. Should there be a global framework for regulating high-energy physics experiments, just as there are international treaties around nuclear weapons and genetic modification? Some argue that pushing the limits of reality at the quantum level should come with checks and balances. The concern isn't just about catastrophic failure, it's also about responsible stewardship of knowledge. Once a discovery is made, like a new state of matter or a method for altering the vacuum state of space, who decides how it's used? At the same time, it's important to recognize the LHC's contribution to facility education. It supports countless PhD programs, internships, and research fellowships. It's not just building our knowledge base but instructing subsequent generations of scientists and engineers. These people frequently use their skills in other industries, helping to advance innovation across the board. The LHC's influence spreads far beyond physics, into computing, communications, electronics, and even finance through complex modeling techniques. What also makes the LHC unique is its humility in the face of the unknown. Unlike some areas of science that work with clear hypotheses and anticipated outcomes, physics accepts that not every experiment will yield definitive answers. Many discoveries at the LHC have taken years to verify and are still being debated. This patient approach to uncertainty is a vital lesson in a world increasingly obsessed with quick results and instant gratification. And finally, the LHC challenges our understanding of the universe not just in scale, but in purpose. Are we trying to decode the universe because we can, or because we believe it holds meaning for us? Are we driven solely by curiosity, or is there an underlying hope that through science we can answer age-old philosophical questions about existence, purpose, and even consciousness? Whether or not the LHC ultimately reveals the secrets of real dark matter or extra dimensions, its value may lie in what it represents: humanity's unending quest to explore, to ask, and to understand. It reminds us that most of the time, the biggest leaps start with the smallest particles, and that even when we peer into the fabric of the universe, we're also looking at ourselves. This deep introspection prompted by the LHC doesn't just affect scientists. It ripples into classrooms, policy rooms, religious discourse, and art. When humanity builds machines that can recreate the earliest moments of the universe, we are forced to reckon with questions we've often left to philosophers or theologians. What is the origin of everything? Can the laws of physics explain consciousness, or is there something more? The LHC doesn't provide easy answers, it magnifies the mystery, showing us that every solved question reveals deeper unknowns. Moreover, the LHC exemplifies how science today is no longer the pursuit of lone geniuses in isolated labs. It is a massive, interconnected system of cooperation and infrastructure. The collider relies not just on theoretical physicists, but on engineers who maintain the magnets, software developers who build analysis platforms, and data scientists who mine meaning from terabytes of noise. It is an ecosystem of expertise, and a reminder that progress often comes not from individual brilliance alone, but from collaboration. In this way, the LHC serves as a microcosm of how humanity can solve problems at scale, not through competition, but through collective effort. Another important consideration is how the public perceives such endeavors. Scientific illiteracy can breed fear, and when people don't understand what the LHC does, they may imagine worst-case scenarios. Conspiracy theories abound, from black holes swallowing the Earth to timelines splitting apart. While unfounded, these ideas reflect a real need for better communication between science and society. This is where public outreach, education, and media representation become critical. The success of the LHC is not just in what it discovers, but in how those discoveries are shared with the world. When the Higgs boson was confirmed, it wasn't just a win for physics, it was a moment of global celebration. People from all walks of life glimpsed the power of scientific curiosity. They saw that even the most complex ideas can be explained, appreciated, and even felt emotionally when communicated clearly and honestly. Looking forward, the LHC is not the end, but a foundation. Plans for more powerful colliders, like the Future Circular Collider, FCC, are already in motion. These projects aim to reach energies far beyond what the LHC can achieve, potentially opening new frontiers in understanding gravity, time, or the very shape of the universe. But with these ambitions come even bigger responsibilities. As we probe deeper into the structure of space and time, we must ask not only what we're doing, but why. Science without reflection risks becoming blind progress. Reflection without action risks stagnation. The LHC, at its best, represents the balance between these forces. It is both bold and careful, ambitious and humble. It dares to explore the unknown, while acknowledging that some answers may never come, or may come at a cost we must be prepared to bear. In the end, the Large Hadron Collider is more than just the sum of its parts. It is not only a particle accelerator, it is a mirror. A mirror that reflects our capacity to wonder, to reason, to collaborate, and to dream. And in that reflection, perhaps, we catch a glimpse not just of quarks and leptons, but of who we are, and who we might become.